Hi everyone, we are from Group 3. Would like to present our project of straw tower building in the subject of solid mechanics, code course BNJ 20903, section 1. This subject is conducted by our dearest lecturer, technologist Dr. Nur Aini binti Marsi, and this project consists of 4 members, Elijah, Muhammad Adam, Muhammad Uzmana, and myself, Siti Sarah.
Assalamualaikum warahmatullahi wabarakatuh, and hello, my name is Muhammad Adam bin Samsularisa, CN 200234. We present the problem statement and objective of the group project. For the problem statement, as stated in the project rubric, a group of 4 students have been asked to build a model of loading bearing tower by using straw. These are the specifications that given in the rubric for build the loading bearing tower, which is the first one. The weight of the loading bearing tower must not more than 0.7 kg. Secondly, the length of the model should be 25 centimeters. Third, the width of the model should be 25 centimeters. And lastly, the width of the model should be 30 centimeters. While examining the greatest force applied to the structure, we need to propose a design solution to determine the stress-strain relationship, beam deformation and deflection, torsion, thin cylinder, strain and stress transformation, column, strain energy, and load-bearing tower failure theories which will be involved. For the objectives, at the end of the topic, students will be able to explain the concept of stress strain, beam deformation, torsion, thin cylinder, strain and stress transformation, column, strain energy, and failure theories. Next, students are able to explain the important principles of structure deformation. The third one, use the principles to determine the stress formation. Define the concept of Mohs circles, and lastly, are able to show the relationship of stress and strain using straw tower experiment. For the objective of the project, the firstly is to demonstrate a good understanding and commitment within a group in solving the given problem. Next is to study an engineering problem and propose an appropriate solutions based on the knowledge of solid mechanics. And last but not least is to write a technical report related to solid mechanics project. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Uzmana bin Muhammad. I will present the methodology of the project. Firstly, I will present about research strategy. In order to obtain the required data to satisfy the objective of the project, a setup of planning is done systematically to allow further information exchange between members. The main focus is generally in the data collection, which was done by evaluating reliable resource. Apart from that, the hardware requirements must be known to allow further progress of the project, which is to build the tower for acquiring important data. For the next one, data collection. During this phase, we establish the project's resource and requirements, as well as literature research for gathering further material for this project. All of the resources were obtained from the research papers and the internet. We gained some reliable information on straw load bearing and conducted some research on straw load bearing once we received the project procedures. Preliminary design. The capacity to withstand enormous weight without distortion makes rectangles the strongest shape to be implemented to the straw tower. The center of gravity of the of a rectangular structure is more stable than other shapes. The tower is around 25 cm in length, 25 cm in breadth, and 30 cm in height, and must not weigh more than 0.7 kilograms. The substructure is the most essential element because it supports the whole structure, so it should have the greatest load-bearing capability. Beams are the structure horizontal walls that are responsible for bearing all vertical loads and transmitting force to the columns. The upright pillars, which are column, contribute as vertical posts that supports the whole structure and prevent lateral integration by transferring compressional pressures from all other structures. As for the design development, items required are straws, superglue, masking tape, and duct tapes. Firstly, we must form a square with straws, glue all the pieces together, stack the straw frames on top of each other, continue until the joint shape into a cube, place the straws side by side, and glue the straws joined all together. So, yeah. In this slide, I will present to you the prototype design of on-shape. Firstly, this is the isometric view of the project, and this is the top and front view of the load-bearing tower. This is the side view, and this is the final prototype of the product. And that's all. Thank you.
Hi everyone, my name is Silaja Barnabas, and today I'm going to present about result and calculation. Firstly, the result for the durability test is passed by our load-bearing tower. The weight we used are 10 kg, 15 kg, 20 kg, 25 kg, and lastly 27 kg. Next, we should calculate the area of the tower. The formula for calculate area is area equals to width times base. The next calculation is to calculate the weight in Newton. The formula for the calculation is W equals to mg, which is weight equals to mass times gravity, and the gravity is 9.81. As well as the next calculation is stress. The formula for stress is stress equals to F over A. The F is force and the A is area in the formula. Also, the next calculation is strain, and its formula is strain equals to stress over Young's modulus. The Young's modulus is equals to 1325 megapascal. The next slide is about column buckling and bending moment calculation. The formula for column buckling calculation is I equals to base times depth power of 3 over 12. And the next formula for column buckling is PCR equals to pi square Young modulus times I, which is the previous answer from the previous formula, and over k, which is 2, and the length times length. Following this, the next calculation is bending moment, which is the formula is bending moment equals to weight times length over 4. In this slide, we have calculated the Mohs circle and the formulas. The first formula is stress max equals to bending moment times centroid over column buckling, and the second formula is centroid x equals to length over 2. The third one is centroid y-axis equals to width over 2, and the last formula is tension xy equals to tension max. The final slide is about stress transformation. The formula to get stress average is equals to stress x plus stress y over 2. Finally, after get the all answer below, we need to plot the data into the Mohr circle, which is stress axis x equals to 3.68 kilopascal, and the stress y axis is equals to 6.36 kilopascal, and the tension for xy axis is 50.86 kilopascal.
To sum up this project of straw building prototype, our project has achieved the objectives on this project, although we did face a few problems here and there. Secondly, the failure that occurs is due to some error, especially when assembling the prototype. Besides, to make the prototype a successful one, our group has been working on getting the better design and calculation. Other than that, we get to understand more about the application of solid mechanics while working on this project. And lastly, our team also learned as a project about the strategy and content, as well as assessing a particular assignment in its totally, utilizing the criteria supplied and finding success in all of the concepts we have tried. As explained in this project, this may be turned into a lesson focused on the design process that can be finished in one class session or less, or an assignment that covers all aspects of the design process and can be worked on for a week or more. Then, in order to decrease the chance of expensive failure, we must determine which design is more successful in certain situations. Other than that, the tower of straw activity can be posed as developing an inexpensive hands-on model of the design of a tower, in which the number of load supported is indicative of the amount of durability or the amount of pressure to create a greater tie into real-world design. An area worth investigating further is holding a second round of tower construction, which would allow students to reflect on their initial ideas and either modify or update them based on the feedback and experiences gained during the first round of tower building. Other than that, another material can be added in fabricating the prototype to make it become stronger in future projects. Thank you.